You are given a whole number and your job is to find the two digits inside it that multiply together to give the biggest possible product. Keep in mind, if a digit shows up more than once in the number, you are allowed to use it twice when picking your pair. So you just want to return that highest product you can make from any two digits in the number. Advanced level. You know the shape of this one already? Max product of two elements, digit restricted. The only trap is reaching for position instead of value. First two or last two digits instead of the actual top two. Let's skip straight to the parts that bite. Same primitive as trimming top K with K fixed at 2, bid engines, leaderboard heads, anything where you want O space instead of a heap for a constant K. Worth noting explicitly because interviewers will push you toward what if K were variables next. Digits of n, pick any two, maximize the product. No negatives, no zero digit weirdness beyond the obvious. The interesting constraint is just how small n is. Bounds the whole discussion of whether optimizing even matters. Strength and integer chart. Nothing here worth dwelling on. The only real design choice is whether you even materialize the list or fold the digit extraction into the scan itself. Doesn't matter at this end. Single pass top 2 tracking, O1 extra state. The generalization you should already be thinking about. This is a degenerate case of a size k min heap for top k, where k2 lets you skip the heap entirely and just hardcode two variables and their comparison order. On over at most 10 digits, effectively free. So complexity isn't the reason to reject this in an interview. The real reason, it doesn't demonstrate that you can generalize to top k, which is almost certainly the follow-up question. Nothing to optimize here. You could pull digits via mod div instead of string conversion if you wanted to avoid the str allocation, but at nt10 d10 it's not a distinction that matters. Mention it if asked, don't lead with it. The branch order is the whole interview signal. Strictures against max 1 first, cascading the old champion down, then a separate strictures against max 2. Get this backwards, check max 2 first, or use carelessly, and ties silently corrupt the result. This is where most candidates lose points. Max 1 makes 2, done. Worth saying out loud in an interview that this is the only place you touch both trackers together. Everything upstream was pure bookkeeping. N22 is the adversarial input you should throw at this yourself before anyone else does. Duplicate digits, both maximal. Trace max 1, max 2 through both iterations before moving on. The second two fails one fax 1 but passes fax 2 since max 2 is still 0. That's the exact mechanism that makes duplicates work without a separate equality branch. Any implementation that special cases begs max 1 is redundant. The ELIF already covers it correctly. ON time, ON space versus ON time, ON space for the digit list either way. At n time 10 the constants dominate and both are sub-microsecond. The complexity argument here is purely about signaling, not runtime. Only justification for brute force, you need every pair's product, not just the max, or you are asked to return the indices of both digits and want to avoid tracking index alongside value. Otherwise, it's just nested loops out of habit. Call that out if an interviewer offers it as the solution. Duplicates 11, a 0-digit threatens, and the max length input are the three you should preempt before an interviewer asks. All three fall out of the same two-line update. No special casing needed, which is itself worth pointing out as a sign the invariant is right. Max 2 initialized to 0 and updated on strict later against max 2, not equality against max 1, is the one invariant that makes 22 and every duplicate case fall out for free. That's the only line worth memorizing. This is top k with k hardcoded to 2. Next time we bump k to 3, the two variable trick stops scaling. And you'll want a min heap of size k instead. That's the actual follow-up question to have an answer ready for. Quick quiz time. If our number is 199, what's the maximum product of two digits? Pause the video and work it out. Take a second. What are the two biggest digits here? It's 81 because 9 shows up twice and each 9 is a separate digit we can pick from. Second question. Between checking every possible pair and just tracking the top two as we go, which approach scales better on a huge number? Picture how many times each approach loops through the digits. The single pass tracking wins. It's linear time, while checking every pair grows quadratically as the number gets longer.